Hello, everybody. Try again. Hello, everybody. We are going to be talking about significant figures today. Alrighty, let's get going. So, your notes are in your packet for you today. And so, if you just turn to these two pages, this will cover everything that we're going to be covering here. Now, before we get started with significant figures or sig figs, here's what you need to know. This is meant to be an introduction to sig figs. We are not necessarily going to be using sig figs all the time throughout the year. I'll let you know when we do. But more than anything, this is to help you prepare for future science classes because sig figs are important as you move to higher up science classes. So I want to make sure that you are prepared for that. So let's go ahead and get started. All right, we are going to go over the 5 basic rules of significant figures, and then it's practice, practice, practice. I have a bunch of online videos and online tutorials and engagement things that you can do with sig figs that give you the explanation as well as help you practice. So there's a lot of opportunities for you to learn this. This is just one tool, this video, that we're going to use. All right. I'm actually going to have you start off by watching this video on your own to go over why sig figs are important in science. This is Tyler DeWitt. He does a fabulous job explaining all of this. You'll also see if you go and watch other tutorials that I use a lot of his stuff, but he is a fabulous, fabulous teacher. So go ahead and pause this lecture video, go ahead and play the Nearpod video with Tyler, and then come back to this one when you're done. All right, so that's sig figs. That's why they're important. And now we're going to talk about the 5 rules that govern significant figures. So, rule number 1, non-zero numbers are always significant. So, if we look here at these 3 numbers, 592, 5, 9, and 2 are all non-zero numbers, and so 592 has 3 significant figures. 23,459, all 5 of those numbers are non-zero, so this has 5 significant figures. 21, 2, and 1 are both non-zero numbers, and therefore it has 2 significant figures. So, I want you to go ahead and check yourself. How many significant figures are the number 524? Pause this video, come up with your answer, and then come back. Alrighty, 524, because 5, 2, and 4 are all non-zero numbers, has 3 significant figures. Rule number 2, in between zeros are always significant. In between means that zeros that fall between non-zero numbers. So here you're looking and you see 3001, 3001. Because those zeros fall in between 2 non-zero numbers, we count them as significant. So 3001 has 4 significant figures. 45.001, the zeros fall between a 5 and a 1. And so they are counted as significant, even though they are in the decimal. And so this has 5 significant figures. 32,001, the zeros fall between a 2 and a 1. Therefore, they are both significant, and those would be counted as sig figs. So 32,001 has 5 significant figures. All right, your turn. How many significant figures in the number 24.002? Go ahead and pause the video, come up with your answer. 24.002 has 5 significant figures because the zeros fall between a 4 and a 2, which are both non-zero numbers. Rule number 3, leading zeros are never, ever significant. So if you ever see a 0 at the beginning of a number, it does not count. So 0.045, this only has 2 sig figs because the 0 is in front. 0.0045, even though you have 2 zeros here, we're only counting the 5 and 4 here. Sorry, I think I misspoke there. We only count the 5 and the 4 as sig figs, so this number only has 2 significant figures. 0.34, even though that 0 comes before a decimal place, it is still not significant because it is a leading 0, and 0.34 only has 2 significant figures. All right, your turn. How many significant figures in the number 0.0099? Go ahead and pause the video, come up with your answer. All right, in this one, we have 9 and 9 as our significant figures, and these 3 zeros do not count because they are leading zeros. Therefore, this is 2 sig figs. Rule number 4, ending zeros after the decimal point are always significant. So if you ever have a zero that comes after the decimal point, that means it is significant. So 45.90, that zero does count since it is after the decimal point and it is an ending zero. So that is 4 sig figs. 34.000. If you have those 3 zeros following that decimal point, that is implying that you have a very accurate or very precise measurement, and therefore 34.000 has 5 significant figures. 3.0, that 0 falls after the decimal point, and therefore it is significant, and we have 2 sig figs. Alrighty, how many significant figures in 1.00? Go ahead and field a guess. All right, that has 3 significant figures because those zeros fall after the decimal point. Rule number 5, ending zeros before the decimal are not significant unless a decimal follows. So this one's a little different from rule 4. So remember that if the zeros come before a decimal point, they are not significant unless you see that decimal point at the end. So let's take a look here. 500 followed by a decimal point. That is going to have 3 significant figures because it is followed by a decimal point. 8,700 followed by a decimal point. That has 4 sig figs because it is followed by a decimal point. However, the number 200 just by itself, this only has 1 significant figure because there is no decimal point there, and ending zeros before the decimal are not significant. How many significant figures in 1,000? Go ahead and field a guess. All right, 1,000 has 1 significant figure because there is no decimal point following the number. Therefore, the 1 is the only significant figure. These 3 zeros are ending zeros before a decimal point. All right, folks, so when it comes to addition and subtraction, it's a little bit of a weird rule, but it'll make sense. So what you need to do is you need to round the answer to the same number of decimal places as the measurement with the fewest decimal places. So let's go ahead and take a quick peek here at our numbers, or our problem. 23.4 plus 120 plus 122.10. If you were to just do standard math, you would end up with the answer 265.50. However, because we are doing significant figures, we need to round to the number with the fewest decimal places. Well, sig figs kind of helps us figure that out, that this is actually 120, and because that 0 is there, we're actually just going to say that 1 and 2, this hundreds and tens, are the only ones that really count, and so we would round it to the tens place, and our answer would become 270 from 655.50. Most of the time, we'll actually be dealing with rounding with numbers that come after the decimal place, but I did want to give you an example of what happens in this sort of situation. So let's go ahead and try one ourselves. All right, so if we have 10.5 plus 9.51, what is the correct answer? It would be 20.0 because the 10.5 has 1 decimal place, whereas the 9.51 has 2 decimal places, so we round our answer to 1 decimal place, even though the answer, when doing the math, would come out to 20.01, we round it to 3 decimal place, or to that 1 decimal place. All right, multiplication and division. You need to round the answer so that it has the same number of significant figures as the measurement with the fewest significant figures. So for example, if we multiply the numbers 125 times 200, that would equal 25,000. Well, 125 has 3 sig figs, 200 has 1 sig fig, therefore we would round our answer to 1 sig fig, so 25,000 gets rounded to 30,000. 75 divided by 5 equals 15. 75 has 2 sig figs, 5 has 1 sig fig, therefore we round our number or our answer to 1 sig fig, which would be 20. All right, what is 77 divided by 7? Go ahead and calculate your answer, pause the video, and when you're ready, go ahead and start again. All right, so 77 divided by 7 would equal 11 normally. However, 77 has 2 sig figs, 7 has 1 sig fig, so we have to round our answer from 2 sig figs to 1, and so our answer becomes 10. All right, folks, I know I just dropped a lot on you, and I know this was an information dump, but if you have any questions that stand out to you, please post them in our Schoology discussion, and I'll make sure to answer them. But otherwise, practice, practice, practice is going to be important. And the first thing you need to do is to figure out, how well do you understand sig figs? Are you super lost, or could you teach other people how to do this? So go ahead and give yourself a rating from 1 to 5. All right. So here's what I want you to do. You need to get a perfect score on the significant figures screening assessment that is in the folder right now. So in this folder, that is going to show me that you have a strong understanding of significant figures. So here's how you're going to do this. In the sig figs folder, there are video tutorials for each rule and mathematical operation. Take notes as you watch them. They go much more in depth than I just went here, so that'll help you out a lot. There are also multiple online practice opportunities for sig figs in the folder with varying levels of explanation to help explain. What you're going to see is that we start combining these rules, and really the best way to do that is to just jump in and practice. So the rest of the day is just for you to work on sig figs and practice and get that perfect score on the significant figures screening assessment. Please note that every time you take the screening assessment, it will give you a different version of it. So it's not going to be just something you can power through. Take your time, get to know this material. You can take it as many times as you want, but I do want to see you get a perfect score. Alrighty, folks, best of luck to you.